Okay, this is my second attempt at NTI 14 Rhombus Notes. Sorry about that. I don't know what happened to my original video. It either didn't upload or got deleted. So this is NTI 14. Rhombus Notes. Okay, plural for rhombus is rhombi. That's why it says that there. A rhombus is a parallelogram, so it has our original 5 properties of a parallelogram. By definition, opposite sides are parallel. I prefer that to come first. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. Diagonals bisect each other. Now, because it is a rhombus, not only are opposite sides congruent, but all 4 sides are congruent. All 4 sides are congruent. So a rhombus is a parallelogram with all 4 sides congruent. That's technically the definition. Also, a couple of special things about diagonals. The diagonals are perpendicular. Symbol for perpendicular is that upside down capital T. Also, the diagonals are going to bisect the angles. We always said diagonals bisect opposite angles. Diagonals bisect opposite angles. All right, so on this paper, I'm going to look at a couple of examples with you and then have you finish the rest of the page, and there is a document for you to put your answers in there so that you can check your answers. Hopefully that's working okay. Let me know if it's not so we can take care of any problems. Apologize for this, guys. Label your picture with your given information. JK is 12. JN is 7. Now, on this, I think I told you with your parallelograms, if they give you a whole diagonal, so like, for example, if they told us JL was 14, I would, to label that, because that can't really label that, I would go ahead and say 14 divided by 2 is 7, and I would put a 7 on each half. Okay, so keep that in mind. That's how I label my diagonals if they give me a whole diagonal measure. They want to know JM. JM is 12. I like to put that on my picture and in the answer blank. JL, it's my whole diagonal. We just talked about that. Diagonals bisect each other, so the whole diagonal is twice that half. I did have a couple of people having some issues with that on the parallelograms. If you know half the diagonal, just multiply it by 2, and that gives you the whole diagonal. Okay, then they want to know MN. MN. Because the diagonals are perpendicular, this is a right angle. Remember, all 4 of those triangles are small right triangles. And I kind of gave you a heads up, we're going to have to be using Pythagorean theorem. Pythagorean theorem, remember, is a squared plus b squared equals c squared. The c on one side by itself is your hypotenuse. That is the side opposite your right angle. So for these, that's always going to be the side of your rhombus. So in this case, that is 12. So our C is 12. The legs of a right triangle are the pieces of our diagonal. In this case, we want to find one of those. For some reason, I always like to put my X first. It really doesn't matter if you put it in for your A or your B. Either one is fine. So I'm going to write this down. You don't have to write this down. We're going to subtract the 7 squared from both sides. And we'll end up with x squared equals this difference. So grab a calculator, and I'm going to put in 12 squared minus 7 squared. Hopefully you guys can see that. 12 squared minus 7 squared. And when I enter that, I get 95. So x squared is equal to 95, but I don't want x squared. I want x. To undo the square, we do the inverse of squaring. So I take the square root of both sides. So on my calculator, I have to take the square root of 95. So square root is typically the inverse function of your x squared. So I'm going to hit second x squared. That gives me my square root. And on this calculator, if I just hit my up arrow, it highlights my 95, and I can just hit enter again. I get 9.746. I'm going to round that. I look only at the number directly behind. I'm going to round to 1 decimal place. I'm sorry. Rounding to 1 decimal place. So I look at the second decimal place. That is below a 5. So I just chop it off. So my answer is going to be 9.7. If this second decimal place is a 5 or greater, I would round up. So if this were a 5, actually a 5, don't round it up to a 5. If this were actually a 5, my answer would be 9.8. But because this is just a 4, my answer is 9.7. So 9.7 is MN. Then they asked me for MK. MK is this total length. That's twice this. So 9.7 plus 9.7. 9 plus 9 is 18. 7 plus 7 is 14. So I'm going to have a 4, carry my 1. I get 19.4. Okay. 2 and 3 are similar to number 1. So I'm going to skip those and jump over to number 4. That is dealing with the angles. Notice they only give us one piece of information, and that seems like, oh my gosh, how can I get all of those answers with only one piece of information? Remember, diagonals are perpendicular. I've got 4 right triangles, and my opposite angles are congruent. Okay, so I really only have 2 different angle measures in there. Okay, and there's a relationship between these. If this is a right angle in a right triangle, what's the relationship between the 2 acute angles? My 2 acute angles are always complementary in a right triangle. Okay, notice the same information keeps coming back up, back up, back up. Okay, in a right triangle, the 2 acute angles are complementary. So to get, well, real quick, what's angle 8? 90 degrees. Okay, to get angle 7, these two have to add to equal 90, because in a triangle, it's 180. 180 minus 90 gives us 90. These two have to add to equal 90. Always in a right triangle, the two acute angles have to add to equal 90. So 90, 90 minus 38. Okay, I'm going to borrow from my 9. That makes that an 8. 10 minus 8 is 2, so that's going to be 52. So angle 7 is 52 degrees. Okay, so now I know my two angle measures. This is 52. If that's 52, angle 6 here is 52 as well. The diagonal bisects the angles. Jump over here. Opposite angles are congruent. That means 1 and 2 are both 52 degrees as well. Okay, come back to the original angle it gave us. If this is 38, angle 3 has to be 38. Diagonal bisects the angles. So angle 3 is 38. So it looked like a lot of work, but it's really not. Opposite angles are congruent. That means 4 and 5 have to be 38. So almost no work whatsoever. Boom. We've got that all filled in. Okay. So seems like a lot of work, but not really. Because really there's only two different angle measures. The key is where do they go? Okay. So hopefully that helps you out. Honestly, guys, the hardest thing on this is doing your Pythagorean theorem, okay? Be careful on that. Remember, your hypotenuse is what goes on one side by itself. If you know your two diagonals, which I think that's what happens down here in number 3, if you know your two diagonals, then those go together and you are finding your side length. Okay, so it would be this number squared plus this number squared, and then just take the square root of that sum. Okay, good luck. I am so sorry about that video not uploading. Hopefully this one gets up okay and you guys are all good. Take care. Rainy day, good day to catch up on some work. So I'll get this up. And I'm going to go ahead and do my video once this gets up for the squares. So if you want to take advantage of a rainy day and get ahead, I'll go ahead and do our NTI 15, which is going to be the back of this paper, which is the squares. Take care, guys. Stay safe. Keep it locked down so we can get this nipped in the bud. Okay? Supposedly we are kind of at the peak. So if we can get it knocked out, hopefully we can get back together. Miss you guys so much. Take care.